Today we're going to look at section 9.3. Now this is dealing with geometry mean, and it's dealing with altitude to geometry mean and then leg with geometry mean. So there's two different focal points. So let's talk about geometry mean in the raw. So here's the theorem. Theorem 9.7 states that if I have a triangle, who has an altitude? Now remember, an altitude creates 90-degree angles on both sides. So an altitude makes a 90-degree angle. And then they show it up here in the corner as well. So there's more than one 90-degree angle. So what I'm saying is that the big one is a 90-degree and that each one of these sides then are 90 degrees. So this is A, this is D, and this is B, and the top is C. So what this is saying is, if I'm looking for the altitude of a specific triangle, and I know the bottom base, so say I know A to D and D to B, or A to B, or D to B. So any of the combinations will allow you then to get the other parts. So what it states is, to get an altitude, which is right here, we are going to do CD multiplied together squared. So whatever that length is, CD, we are going to multiply it times itself, which means square it, equals. Now, the length AD will be multiplied times the length BD. So I'm saying take this here and this here and multiply them. So in an example, let's say that I know that, and this is going to be in your note packet, if you look at number 3, this is an example of getting a geometric mean. So let's pretend that AD equals 6 and BD equals 2. Most of the time you'll see it just written as 2 and 6, which is indicators that they're at the bottom when they ask for a geometric mean. So all we have to do to get this is just take and set it up. So we don't know what this is, so let's call the CDX. So it's going to be x squared equals 2 times 6. So x squared is going to end up equaling 12. So the 9.7 theory states that I have to give it exact. So in the exact, we are going to take and square root it. So x equals the square root of 12. Because to undo a square, you must do the square root. Now, the computer is going to want it put in exact terms. And exact terms is going to end up equaling x equals. Now, if you don't recall, go back to the 9.1, the rationalizing your radicals, because this is going to be 2 square root 3 as your final answer. So if you put in your calculator, you're going to notice that is roughly 3.46. Okay, so that's geometric mean for number 3. So look at number 4. So for number 4, they gave me 5 and 45. So that means the longer length, which in this case is AD, is 45, and the shorter length is going to be 5. So once again, I'll just kind of label them here so that you can get an idea of what we're doing. We do not know the CD, so we're going to use x again. So x squared equals 5 times 45. So x squared equals 225. And this one turns out to be really nice because when you square root 225, x is going to come out equaling 15. So your altitude is going to be 15. Now remember, CD stands for your altitude. So let's write this somewhere that you will see it and recall it. So this right here is dealing with altitudes, and I'll just put this up here. ALTITUDE, and this is your altitude theorem. Okay, so this is geometric mean, but it's dealing with the altitude part of it. All right, so we've talked about the altitude part. Now let's talk about the geometric mean leg theorem. So this is 9.8, theorem 9.8. And once again, I'll write it down here, geometric, so I put the I in there, mean theorem. And this has to do with the leg this time. Okay, so with this one, it basically states you have two types that you could be looking for. You could be looking for the shorter leg or the longer leg. So let's redraw that triangle that we had up above. There's my altitude. There's that one and that one. So what I have here, again, this is A, D, B, and this is C up top. So let's talk about the two possible legs. So let's pretend that we don't know this one over here or this one over here. So we have two ones that we could be looking for. So if I'm looking for the shorter leg over here, that is going to be CB squared equals DB times AB. So I'm taking the full length times the shorter length to get the length of the altitude of the shorter leg. So for the longer leg, which is going to be this one here, and remember, if this is a right triangle, this is my longer leg and this is my shorter leg, and that is my hypotenuse. So keep in mind, it's all in how you look at the triangle on when they talk about legs in this case. So for this one, we're looking for the shorter leg, so we're looking for AC squared. So now you're going to take AD and times it times AB. So remember that you're doing the longer length times the entire length. So let's do a couple examples with that. So if I'm looking for the geometric leg, the one I'm missing, we are going to be looking at something like number 6. So for number 6, we are going to be looking for this here. So I'm going to redraw my triangle. It looks something like this. This is Y. Of course, this is my C, my B, my D, and my A again, if you put it in that perspective. This is 2, and that length is 9. So by what we have, the AC, so AC is going to be Y equals AD. So that's going to be 9 times, now AB is 9 plus 2. And we know by order of operations, you'd add that before you multiplied. So y squared is going to equal 9 times 11. So y squared equals 99. Now remember, once again, you can't leave it this way. You're going to have to do the square root of it. And 99 isn't a perfect square root, but it has a perfect factor in it. So the square root of 9 is 3. So 3 square root 11 is y. Or if I put it into decimal, that is going to be 9.95. Okay, so that gave me the shorter leg and the long that we have there. There is one other one we looked at. So let's look at one other one that we have here. And this one's kind of bizarre, but it's number 7 and number 8. They are the same concept, but you have to use a little bit of thinking it out ahead of time. So let me move this over here. And let's go over another one. Let me fix my paper here. There we go. So for this particular one, we are going to look at number 7. And number 7 is a very bizarre one. The right angle part is here. And there's this little patch here. So I'm kind of expanding a little bit just to make it a little easier to understand. And from here to here is T. The short length here is 7, and this part of the leg is going to be 49. So here's what we're going to do. We know the shorter leg. So if you look at the theorem, this would be the same as doing the CB. So we're going to use CB squared equals DB times AB. So in this case, I know that this right here is my C, that is my B, that's my D, and that's my A. So if you put it in that context, it's going to make this formula make more sense. So now let's plug in what we know. We know that CB is 49. So 49 squared equals DB is 7 times T, because the full length across is T. So be careful, don't forget to do your exponents first. So when we do our exponents, we're going to get 2,401 equals 7T. Well, we know how to handle this. This is just an algebra problem. So I divide both sides by 7. So T equals 343. So as you can see, this formula applies to missing the bottom part of my altitude. All right, so let's look at one more, number 8. Now, number 8 is a tad different from number 7. What's going to happen with number 8 here is that we have to set this up in proportions, in a sense. And I know you're thinking, well, we didn't have to do those the others. Well, that's true, but in this case, you're going to see what I'm talking about. So this is 6, this is 3, this is A plus 4. All right, so here's what happened. We have the altitude. So I actually know what the geomic altitude is. So what we're going to do is take the formula that we use to get geomic altitude, which is x squared equals the two means, or the two bottoms. And that right there is going to be, in this case, if I put some letters in here, that, by the way, would be my altitude in this case. Let's see here. So let's make this our C. There's our A. There's our D. And there's our B. So when we do this, our geomic altitude statement tells us that it is x squared equals AD times BD. Okay, so this right here is going to be 6 squared equals, now I'm going to go ahead and put the number out front, so it's going to be 3 parentheses A plus 4. All right, now what I have here is, since I didn't have the full length, I'm going to go ahead and just multiply them. So this right here is 36 equals, do your distributive property for the multiplication, 3A plus 24. I'm sorry, 12. I started to give myself away the answer already. So this is actually a 12, not 24. My fault. When you subtract 12 over, that's where I got my 24 from. So that's 24 there, equals 3A. Now go ahead and divide both sides by 3. So A is going to equal 8. So finding the missing A in this case was just finding that there. So if I wanted to put it back in and find what the length was, all I have to do is substitute 8 back up here to the original problem. 8 plus 4 is going to end up giving me 12. Okay, so that finishes 9.3. There are other examples you can go back through and look in your textbook. If you have any questions, just remember you know how to get a hold of me. Good luck.